Welcome to Ask and Learn.
We'll start with the interval of convergence. The interval of convergence is the largest interval for which your power series converges. And the radius of convergence is just half of the length of that interval. So say that your interval of convergence was something like minus r to r, could be open, could be closed, could be half open, whatever. Then your radius of convergence would just be r. Okay, now you can find something like this by taking your power series. So let's say it looks something like this. And if you did the ratio test, then you'd see that you would need, for limit as n goes to infinity, of absolute value of a sub n plus 1 over a sub n times x. That would have to be less than 1. Okay, but then this is just going to give you some open interval. And then in the cases where you get equal to 1, the test is inconclusive. So you just need to check the cases where x is equal to 1. You just have to check that separately. You can use this to figure out what r is. Okay, so if this happens, then your r value is limit as n goes to infinity of the absolute value of an over an plus 1. Okay, and then you know that your interval is going to look something like minus r to r. Unclear whether or not this should be open or closed here. Unclear whether or not this should be open or closed. But you just have to check the endpoints separately. So take minus r, plug it into your sum, figure out whether or not you get convergence or divergence. If you get convergence, then you'd want to include that in your interval of convergence. If you got divergence, then you'd leave this part open. And similarly, you'd have to check r, figure out whether or not that should be included or thrown out.